Hello everyone. So today is gonna be our day. We've already completed 8 days. So yeah, today is gonna be on day 9 of the DSA challenge, right? So today the question that we are gonna solve is merge two solid arrays with extra space without extra space. So see, this question is slightly different on different platforms. So for example, on GFG, that is Geek for Geeks, you will find it a little different from what it is on the Leetcode. And I'm not sure of coding ninjas, but you can probably check for yourself. But since we are doing this on lead code only, so we'll solve the lead code variation, right? So the question given is you are given two integer arrays, num1 and num2, sorted in non-decreasing order. That is, they are sorted already in ascending order, and two integers m and n representing the number of elements in n nums1, that is array 1 and array 2 respectively. You have to merge it into a single array so that it is sorted, so that that array is also sorted. Great. Let's read this thing afterwards. Okay, you don't have to read it right now. We probably, I mean, obviously this is the part of the question that we'll solve, but let's see how this question is going to be solved, right? Let's take this. Okay, I will paste it here and I will remove these three zeros. Obviously, these zeros are going to be a part of the original question, but let's solve this question. Okay, so you have to solve. Also, I might so when I'm gonna discuss this question, I might go on to explain a little bit about GFT's solution as well. So the question that is going to be there, or the variation that is going to be there on GFG. So yeah, let's take it, right? So you have to merge these two arrays, right? You have to merge these two arrays. And from what I have heard from the interviews perspective, is that you won't be asked to, merge it into a single array or something, right? You will just be given this question. So basically, you won't be asked to, like here it is written without any extra space. You won't be given that you don't have to use any extra space. You will be given that you just have to merge two arrays. So what is the brute force, right? Brute force. Great. Let's see. Let's take another array. Mm, let's take nums 3, which is going to be an empty array, right? Let's do one thing. Okay, sorry, I'll just take yeah. So very simple in JavaScript keys, you just have to spread nums1 here and just spread nums2 here. So what would num3 will look like right now? It will look like something like 1, 2, 3 and 2, 5, 6, right? It is going to look like this. And you simply do nothing. You just say num3 dot sort uh, what just do give it a comparison function and just say a minus b, and I think you are good to go. You will get receive num3 as 1, 2, 2, 3, 5, and 6. Great, very easy, right? It seems easy. So let's discuss the time complexity for it, right? You are spreading it. I don't think it will take any I think spreading takes this. Uh, so assuming that spreading is also used, I'm not really not sure. You can just probably check on the internet. But from what I understand, spreading means you are running a loop, right? Because you will be spreading these values one by one. Not sure. Maybe it could be constant time. Maybe I'm not sure. But from what I understand, it should be O of the length, right? O of length. So O of m plus O of n, right? I think it should be that only because you'll probably run a loop to, spread all the values of nums1 and then you will run a loop to spread all the values of num2. Doesn't matter. We can skip this part. I mean, since I'm not sure of it, you can probably see on the internet like what is the time complexity for spreading. Let's discuss for sorting. We have already discussed that num3 is what is the length of it? It's m plus n, right? So since this is m, this is n, right? So value length of num1 is m and value basically the length is num2 for n for num2. So So sorting will take m plus n log m plus n, right? Logarithmic value. So this is what sorting sorting time complexity is. And what is the space complexity? We are taking uh, an extra space of O of m plus n because we are taking an array with length m plus n, right? So this is going to be our brute force solution. I mean, that is something that is coming to our mind. Maybe I'm wrong. Maybe there is another brute force for it. But since brute force, I basically what I think, is that people misinterpret the name brute force. Basically, brute force should be something that is quickly coming into your mind. I'm not sure if optimized solution should come into your mind. Obviously, if you're giving your interview, you have to tell the interviewer the very the algorithm that is taking the most time because you have to optimize it later on. You cannot just simply go and say like, hey, I can do it in linear complexity. The interview will obviously think that you already know this question and might reject you for that reason, or maybe he won't reject you or even ask you a difficult question after it, right? So obviously, to think of it, you can think that brute force is there, for at least for me. And okay, so let's say that we have to, what we have to do is we the GFG version that I'm talking about right now, we'll come to the lead code solution variation later on. But in GFG, what you're given is you'll be given um, nums one, right? You'll be given nums one, which is nothing but 1, 2, 3, and you'll be given nums two as 2, 5, and 6. What you have to do is you basically have your output should be nums one should look like 1, comma 2, comma 2, right? And your nums two should look like 3, comma 5, comma 6. So basically, if you will see that this is what our required answer was, right? 1, 2, 2, 3, 5, 6. So if I basically have any other array, so if these two values are combined, 1, 2, 2, 3, 5, 6, this is what it looks like. You just have to have the first sorted solution, first m sorted position in indexes should be nums one, and last, so basically m plus what you can say is basically after m plus something, you have to have these values in nums, right? This is what your solution should look. Let's discuss what we can do here. Again, obviously, since we have discussed the brute force, I'll probably move on to an optimal solution here of the one. Okay? Great. Let's see. Let me write it again. So nums one is 1, comma 2, comma 3, and nums two is 2, comma 5, comma 6. Great. Let me zoom in a little so that you can see better. Uh, uh, Great. Let me put a counter here, a pointer here, sorry. Give me a second. I know I'm bad at it. So if I say that you will make a pointer here and another pointer here, basically, right? You will take another pointer here. Okay. So I'll name this as left, this as right. Perfect. No problem. I will compare that if my value at L is greater than my value at, sorry, at right. So if my value at L is greater than value at right, what do you think should actually be should happening, right? If this is true, if this is true, then obviously you have to swap these values, right? You have to swap these values. Now, why am I saying you have to swap these values? Because you have to have all the greater values in nums2 and all the smaller values in nums1. That's what your um, ideology should look like, right? So let me swap. Let me say that this is going to be 2 and this is going to be 3. So if I say val1 and val2. I mean, assuming this is val1 and this is val2. This is not v. This is obviously going to be this is going to be nums2 and this is going to be nums1. Right? I hope you understand. Obviously, I'm just not writing all these things. I hope you understand. Great. Let us move to this thing now. Now, obviously, we'll say that left minus minus and right plus plus. Great. Yes. So if I say that if, again, I'll just check this condition, right? If this is my condition, then 2 is 2 greater than 5, you will say. Obviously, no. Then what you have to do? Great. Let's think about. Obviously, you can say that, okay, no problem, just continue and go for another loop. But hey, listen, if L is not less than, if my 2 value is not great, if no, is not greater than 5, do you think if I go beyond this value and above these values, they will get, they will probably pass this value? Think again. No, right? Because it is given in the question that these arrays are sorted, are already sorted. So if 2 is not greater than 5, then how will 1 be greater than 5 or 1 will be greater than 6, right? So no, you don't have to do anything. You'll just say else break, uh, else break, right? I think you have gotten your solution, right? This is your solution, and this is what it should exactly look like. Let's discuss our time complexity for it. You are running a loop of L. Basically, the left pointer, you are moving M position and you're moving your R for N positions, right? So M positions and R positions. Obviously, there are going to be cases where it will break, right? It might break on the first go. It might break on the second or third iteration, maybe or fourth iteration, maybe. You don't know. But you just have to assume the worst case possible, right? So let's say that it runs for O of M plus N. Am I right or not? You just tell me. Obviously, there will be, let's say, this is this is again not right, right? Why is it not right? You will see that either, either, no, either is only for two things. So there could be three cases, right? Where M is equal to N, M is greater than N, and M is smaller than N, right? If this is equal, no problem, right? But if it is greater than N, then probably this loop will break when N is when R reaches N, right? This will this loop will break. The while loop that we'll going to execute will probably break when when R reaches N, or in this case when N reaches M, this loop will break again, because obviously we have to have that condition that while L is greater than equal to 0 and R is less than equal to less than. This is what our condition for the while be looking like. So obviously the time complexity is not O of M plus N. You might think that it is running for a single iteration, sorry, but it is O of minimum of M comma N, right? Great. This is what the time complexity should look like. There is obviously another optimal solution that is called gap method, right? And it is inspired by a sorting technique called shell sort, right? And it is not difficult. It is not that difficult. You just have to assume that these are the values 1, 2, 3, 2, 5, and 6. You just have to start your L counter from here, and you have to have a gap which is equal to M plus N divided by 2 and take the seal of it. So, sorry, take the seal of it. So what is M plus N? It is 3 plus 3, that is 6. 6 by 2, which is 3. And what is the seal of 3? 3 is the 3. So you will start your gap with 0, okay, 1, 2, 3. You will start your right counter from L plus gap, right? You will again swap the values. If one is less than, again, if this position is less than this, greater than this position, then you will swap or else you will move forward. So if this is not correct, this is L, this is R, right? And 2 is less than no, then you will come here and then you will say that R comes here. If this is great, yes, this is true. No, this is not true. Sorry, this is not true. Because R is 5 and L is 3. So no, L moves here, R moves here. Again, no, your R moves out of it. Then again, you take, you know, your gap. I think it get divided by 2. So if it was 3 earlier, then you will divide it by 2 and again take the seal of it. So seal is going to be 2 now. So again, you start your your counter. Sorry, I have to move it also. So L is here, R is here. No, L comes here, R comes here. Great. Still no. L comes here, R comes here. Still no. Right? This is again not going to be true. Again, if we take the division of it, what is going to be a division of it and seal of it? It is going to be 1, right? So R, L here, R here. Not true. L comes here, R comes here. Not true. L comes here, R comes here. True. So 2 and 3. Again, R goes here, L goes here. Not true, and R goes out of it. And if it has now, if it obviously when you will divide it by 2, you will get 0 0.5, but the seal of it is 1. Again, you will get 1. Obviously, you'll be stuck in one loop only, in a infinite loop. So you have to break after you have already done one, right? If you have done one, you have done one once. If the gap has already been one, you will break. You will just break the loop, and you will see that this array is now sorted 1, 2, 2, 3, right? This is gap method, and again, this take O of minimum of it doesn't take minimum of m plus n. It basically takes m plus n kind of a thing, but it's not. I mean, obviously, it depends upon you. Let's quickly come on to the lead code one. Now that you've understood how these things work, let's understand what lead code says. What lead code says is, so if I just copy it and simply paste it here, you will notice something that these are three zeros added, right? And num2 also has three values, right? Num2 has also three values. Great. So if I say that somehow I just and what I mean, obviously let's see what the output is. This is the output required. Now you will say that, hey Rohan, if this is the output required, I can obviously take another array and check if the zero is basically. Let's not beat around the bush. What you have to do is these three zeros means that this num1 is given a length of m plus n already. Already it is given that length. You just have to push these values in here somehow and get this num1 sorted. And obviously, before moving forward, this is the constraint. This is the constraint. So nums I and nums j can also be zero. They can also be zero. But the the last m zeros, sorry, n zeros are designed in that way that it is for num2 value only, right? You have to do something like this. Great. No problem, right? What you can do is uh, let's just directly jump onto the brute force, right? Sorry, to an optimal solution. Okay, great. Let me just copy these values and paste it here again. Okay. I'll say that I'll put my counter here. I will name it probably as position, maybe, right? Position. My M counter is going to be here. My N counter is going to be at this position. So if I have this, I will say that this is my pause. Uh, this is my M and this is my N. Great. Let me erase this so that I can, these things. Okay. Uh, how do I make it bigger? Maybe I can call it M, right? I can call it M. Or I can say that this is L and this is R, right? I don't want to play around with M and N. I just want to give it M, L, and R. Great. Okay. I will run my loop till, till, right? Till N is greater than 0. Why am I doing it? Because I will do something like I will fill these values in that iteration only, and you will see that nums1 length will always be greater than nums2 length. Why am I saying so? What is the length of nums1 right now? Although it is given 3, and even if you print it, it will give you 3 only. I guess I'm not sure. I haven't printed it, but yeah, we'll check that later on. But yeah, but we know that its value is m plus n already given in the question. So what is m plus n? It is 6 right now. So the length is going to be 6, and 6 will always will sorry m plus n will always be greater than n. Is that so? Yes. So while my sorry r is greater than equal to 0, since I'm starting it at the end, right? Great. If this is true, I will check some condition. I will check some condition. I will check L and R. If my array 1 of L is greater than array 2 of R. If this is true, do something else, do something, right? We'll see what we have to do. No problem. Let's see. If L is greater than R, is 3 greater than 6? You will say no, Rohan, it is not. Let's simply do that this position, that num1 position, then let me type it, it would be better. Nums1 position should simply look like nums2 of n, and I'll say n, sorry, not n, r minus minus, and here also it should be r. True? Why? If I change it to 6, right, and move my pointer to backward, do you think that this is the required thing that I am pushing it in here? Can I push it at 3 position? If I push it at this position, if I push it at this position, will it be sorted? Right now, is it sorted? Let's see. Let's consider that these two values are not there. These two values are not there. So 1, 2, 3, and 6. Is it sorted? Yes. Yes, it is sorted. Great. No problem. We have already moved backwards, right? We have moved backward. And I'll say at the end that, hey, you need to do my position minus minus as well. Or let me not do that. Let me not do. Let me do it here only for you guys, and we'll later on change it. I'll say that position minus minus also, obviously now that this position has been filled, you have to move this counter, right? If you move this counter, then only you will be able to access the second last value, right? So where is it? Yeah, this is our thing. Now position minus. Great. Is my L, right? Is my nums1 L the less than R, less than nums2 of R? No. I mean, no, it is not greater. It is not greater. Again, you will do. what you'll do is you will say that, hey, this is going to be 5. This is going to shift yeah, this is going to shift backwards and position also will move backwards. Here it is the position. Great. Now again, is array 1 of L greater than array 2 of R? Is 3 greater than 2? You will say no, Rohan. We are in the L position now. We are somewhere here. Then what you have to do? Then what you have to do? Okay. I'll say that do nothing. Just change this and keep it 3. You will say that how can you do it? How can you do it? I will say that hey, listen to. Maybe this value belonged to nums 2. Maybe this value belonged to nums 2. I am had it been 3 here and 2 here, you would have pushed it to this position when you will come in this if block, right? Had it been 3 instead of 2, you would have gone to this iteration, not else block, right? Then also you would have done the same thing. I'm saying that okay, no problem, do this. But now just simply move my L counter here and again position counter here. Okay, no problem, no problem. Do nothing. Okay. Uh Compare again. Okay, let me write it here. No? It would be much better. Let's say that nums one of position should look like nums one of R, sorry, L, and I'll say that hey, L minus minus and 4 is also minus minus. No problem. Great. Again, now if L is lesser than R, sorry, greater, if L greater than R, you will say no, Rohan, it is not. Do nothing. Do nothing. Just remove, sorry, not remove it. Basically, just remove this value, the positions value, and keep it as 2. Just basically move it here. Move it to the positions value. Great. R, and you will say that hey, L minus minus. Where is this? Yeah, L minus minus position minus minus. Position is pointing to the second index, and L is pointing to the first index. That is 0, and position is at 1. Great. You will again compare the same thing. Is array 1 of L greater than array 2 of R? Is 1 greater than 2? No, brother, it is not. Then what you have to do is nums of position 1 is equal to nums of position 2. That is this value. This value should be equal to this value. Where is this? Just remove this, go this, and you will say that hey, L R should be minus minus. It is pointing out of what you call it will break. It because this condition is not true now, right? This position is not true. And then you will come out of the loop. You will be here. So is my array sorted now? So what is it? One, let me write it again since it's very ugly. It is something like 1, 2, 2, 3, 5, 6. This is what my nums one look like, right? Are we getting this value? Yes, we are getting this value, right? We are getting this value. Great. This is what we required. Is this what we needed? Yes, this is what we needed. We've already solved it. Right? We've solved this question. So let's just directly jump onto the question or the code, and let's write the code, and we'll understand later, right? So before even doing anything, let me write nums one of length and check what is the length given. Is it 6 or is it 3? And it is 6. So right, this is m plus n greater than it, right? Greater than n always. Okay, what I was saying is that hey, I'll say let pose is equals to nums one dot length minus 1. So I'm keeping it at the last index of nums1. That is the uh, 0, 1, 2, 3, and 4, and 5, the fifth index, or the sixth index, basically, means sixth index. And if you say if you say the number, that means then it is 5. This is this. Let R equal to n, n, sorry, L equal to n, right? Correct? This is what we discussed. So I'll say that, hey, while R is greater than equal to 0, yes, great. I'll run my loop. If nums1, as we discussed, it should be m, sorry, not m, it should be L, is greater than nums2 of R. Then what it should be? Then what you need to do is you need to nums1 of pose is equal to nums2 of R and R minus minus. Else nums1 of pause is nothing but sorry, why is my laptop acting weird? Is nothing but nums1 of R, sorry, L, why I put, and L minus minus. Is it true? Yes, it is true. And every time do pose minus. In either of the conditions, we are doing position minus minus, right? And we don't have to return. Let me just put my laptop on charging since it's blinking. Sorry. Yeah. Since every time we are doing a position minus, right? And let's see how our nums1 is looking like. Although we'll already see it, but again. Mm, let's done. I think we are done with that with this variation, but let's see if there's any problem in it or not. Okay. TLE exceeded. Great. Why is that? Why we are getting TLE? N, okay. It's N. It should be N minus 1. It should be M minus 1, right? Can we check again? And are we getting TLE again? Okay, TLE again. Why is it so? We are using our right counter. R is N minus 1, L is M minus 1. Okay. Let me just pause it and see what's the problem. So guys, I think there's some mistake I think I did, and it should be like this, right? It should be opposite of it. So if I say that nums1 of L, okay, where is it? Nums1 of L. This is M, this is L. If it is lesser than this value, then only basically you will, put this value here, right? I'm sorry if I put this. If it is greater, then you will put it here. But if it is lesser than it, then only you will put it in the end, right? Is this what we are doing here? Yes, I think this is what we are doing here. Let's try and run it again. Uh, I will check. I think I'm getting TLE again. I think there is a problem. There is a problem. Okay. Let me just see what is the problem, right? Give me 2 seconds. Guys, so basically what I did was Let me just remove this floating meeting control. I explained you the right concept, but I think I kind of, you know, miswrote this condition. Let's go on what our conditions are, right? Let's copy this and we'll understand it. Obviously, let's first submit it and then we'll later on see, right? Let's copy this while loop. Okay, copy it. Try to submit it, and I think it should get submitted. I don't think there's any problem here. Mm, Just get accepted. Great. So we just copy it here, and let me delete this. Yeah, this is our while loop. Let's quickly write what our positions were. Pause is nothing but um, nums1 dot length minus one, and r is nothing but m minus one. R, sorry, L is n minus one. And let's quickly copy the given input, right? Let's copy this and let's go over, right? This is what num1 should look like. So what is our position? It is 0, 1, 2, 3, 4, 5. It is 5. What is my R? R is 2, L is also 2 here. Okay. If is R greater than 2, so basically my R is here, my pose is here, my L is here. If I just remove this instead, my L is somewhere here. Great. Let's see if nums1 of L, that is, if this position is greater than this nums2 of R, nums2 of R. Let me see what I wrote here. Nums2 of R. Okay, let's quickly go through this code. So nums1 of L is greater than nums2 of R. So if 3 is greater than 6, if it is true, then do this, else do. Is it true? No, this is not true. So nums1 position is nothing but it should be 6. Great. We move our R here and pose here, right? Great. Is is L greater than R? No, put 5 here. Uh, Move my R backwards. Great. And pose also should come here. If is 3 greater than 2? Yes, it is 2. Then what do? Then do nums of 1 of pose, that is this, is equal to nums1 of L. So this is what we need to do. I think this is what we discussed, right? This is what we need to do. Great. L minus L comes here, right? L comes here, and also position should come here. This is position, right? What is my R here? R is actually only. So again, is R greater than 0? Yes, it is greater than 0. Greater than or equal to 0, sorry. We'll check if nums1 of L greater than nums2 of R. Is it true? Is 1 greater than 2? No. So we'll do R minus minus, and this 2 should come at this position. This 2 comes at this position. R minus minus, R comes here, P comes here. Is Will this loop run now? No, it will not run. And I think we have already solved this question. I was making a little mistake there when I was, not, what do you call it? I wasn't writing these conditions well, but I explained in the right way. Maybe I did some mistake. It's a human error, so you can probably, see for it. But yeah, what is the time complexity, right? Let's discuss the time complexity. It should be what it should be. Since we are running till R, we are running for R, it should be O of M, but it is not. It is not. Because we are somewhat moving our pointer also, we are moving our L also, we are moving our right also. So we can say that it is M plus N. somewhat, somewhat maybe. How many iterations are we doing? One, two, three, four, five. So in this particular example, we are doing five iterations, right? We're doing five iterations. It is almost equal to m plus n, or is it almost equal to m? Is 5 near to 6, or 3 near to 5, right? Obviously, you'll say that 6 is nearer, right? So we can say that time complexity is is the upper bound is O of m and n, and space complexity is obviously O of 1. So no extra space taken, and we have solved this question. Solved. I like to do all these. So thank you so much, guys, for joining in. I'll see you tomorrow again with another question. I guess day 10 we'll solve tomorrow. And see you then. Thank you so much.